Hi everybody, this is Mr. Zarzik, and in this screencast I'm going to focus on problem solving with horizontally launched projectiles. So let's get right to it. In class we developed a general problem solving approach to these kind of problems, and we also did a lab on it. And in both cases, the key to working these kind of problems is the time. Alright, and we're probably going to need to solve for that, but once we have that time, okay, well then we can consider both the horizontal and vertical dimensions independently of one another. And in each case, there's some things that we can assume or some things that we know. All right, so I'll address these when we actually get into working a problem. I'll be working off the Vector Projectile Test Review handout, which is available on the course website. So if you'd like to work along with us, I'll be on the back page here for the horizontally launched projectile. And in this question, we're asked to decide a height for a hypothetical cliff and also a landing distance from where our projectile lands from that cliff. So my daughter Lydia was born at 3:07 a.m. on October 4th, so I think I'm going to use that as my sample numbers. My cliff here is going to be 307 meters tall, and we will say that it lands 104 meters away from the cliff. Question 1 says, how long is the ball in the air before hitting the ground? And that's perfect because the first step in our problem-solving approach is to get the time. Before I worry about writing any equations or subbing in any numbers to solve anything, all right, first I'm going to draw a picture of this problem. Now, you might not be very good at drawing, and well, honestly, neither am I, all right, but a quick little simple sketch, and honestly, the simpler the sketch, the better. All right, can really make working these problems a lot easier. So I'm going to make a quick sketch. So this is going to be my cliff. All right, and my projectile here, this ball that gets thrown horizontally, okay, is going to move through the air. It's going to make an arc. It's going to land somewhere over here. All right, as far as the important information, all right, one, I've got the height of the cliff. So the height at which I throw the ball, okay, we call that dy. That's the vertical displacement. So it's how far down the ball is going to move. And, well, that happens to be the 307 meters that I chose. So I'm just going to write it over here. So I'm going to write dy equals 307 meters. All right, and the other part is what we call the range. All right, so what happens here is the ball winds up landing some distance away from the cliff. All right, we call that dx. Now, I understand that the ball moves through in this arc, but trying to measure the length of this arc, well, honestly, we really don't have any physics equations to do that at this point. So it's much more useful to just say, you know what, this is the base of the cliff, and the ball lands over here. So really, it's this range, this dx, that we're interested in. All right, as far as how long the ball is in the air, all right, well, that's really a matter of why the ball hits the ground in the first place, and that is, of course, gravity. See, because the ball is thrown off the cliff with some initial velocity, and, well, if it weren't for gravity, the ball would just go off to the right in a straight line forever and ever and ever and ever and ever. All right, and so we know that acceleration of gravity is 10 meters per second squared, and it points down. Now, you might be tempted to make down negative here, and it's not that you can't do that, all right? If we wanted to make gravity down, that's fine, but then our vertical displacement, this 307 meters over here on the side, okay, that would also wind up being a negative value, all right, because it would also be in the downward direction. So rather than do that, okay, I'm going to back this up here and say, you know what, I think everything in this problem is either down or sideways. So I'm just going to make down my positive direction, and that'll allow me to keep gravity as a positive value so that I don't have to worry about any negatives at all in this problem. I am going to note, though, that the acceleration of gravity, since it's down, okay, that's the acceleration that's going to happen in the vertical dimension. So that's AY. All right, and while I'm identifying all these variables, okay, well, this is a horizontally launched projectile. Horizontal, by definition, is not vertical at all. That's why we call it horizontal. So this initial velocity here, which I don't even know what it is, but it's an initial velocity horizontal. We throw it horizontally. In which case, why that's important is, well, my initial vertical velocity for anything that's launched horizontally, well, that's kind of nice because, see, that's going to be 0. meters per second. As this thing falls, as it moves through the air, okay, it's going to speed up in the downward direction, but to start out with, all the initial motion is all sideways. So that's going to be really useful to us. The last piece of information that I have in the problem is this 104 meters here. That's how far away it lands from the cliff. Well, that's my range, so I'm just going to label it over here. That's dx as 104 meters. And again, this initial velocity in the horizontal direction, okay, well, we don't know it at the moment. So I'll just go ahead and label this Vix as a question mark. All right, and like I said, taking the time to make this picture and identify all the knowns and unknowns is really going to pay off as we work through the problem. That's really the hardest part, is identifying what measurements you're given, what you're asked to solve for, and so forth. So let's get to it. Question 1 says, how long is the ball in the air before hitting the ground? All right, the question is asking us to solve for the time. All right, the time here, that's our unknown. And the reason that the ball hits the ground in the first place, that's gravity. So gravity only acts vertically, so I'm looking in this vertical dimension that we call y. All right, and the key is to look at it from displacement. The displacement equation says d equals VIT plus 1/2 AT squared. And since I'm looking in this vertical dimension, okay, well then really anything that's a vector, I need to label that. I'm going to label that with little y. So displacement y, that's the distance that the ball goes down, is equal to the initial velocity down plus 1/2 times the acceleration, that's a vector 2, that's gravity, times time squared. Well, if I pop back up to my given information, the things that I was able to identify, well, because this is a horizontally launched projectile problem, well, that means that the initial velocity in the vertical direction, VIY, well, that's just 0. And so if I pop back down to my displacement equation here, well, if my initial velocity is 0, well, this entire term just goes away, and I'm left with a simplified version of the displacement equation, d equals 1/2 AT squared, where my job is now to solve for the time. So I'm going to go through and do a little bit of algebra to isolate the time. All right, and so let's see here. So let's see, 2 dy is equal to ay times t squared. I just moved over the 1/2 here by multiplying both sides of the equation by 2. And then the next step is I'm going to divide out that acceleration on both sides. So I wind up with 2 dy over ay is equal to t squared. And then the last little step here is I'm going to take the square root of both sides. And so I wind up with the way to solve for that time is equal to the square root of 2 dy over ay. Now, on a test or a quiz, you might not have the time to go through all the steps to derive this time equation for horizontally launched projectiles. So this might be a good thing to put on a note card, that you have the time for only for a horizontally launched projectile does this work, but it's still pretty darn useful here, where you take 2 times the height divided by the acceleration of gravity, and then you take the square root of that, and that is going to get you the time that this ball is in the air. So going through and subbing in, take the square root, my cliff was 307 meters tall, divided by the acceleration of gravity, 10 meters per second squared. When you're solving this on your calculator, make sure that you're taking 2 times 307 divided by 10 and then taking the square root, so that you don't wind up with an order of operations error. If you do it right, you'll get 7.836 seconds. And again, I'm carrying 3 digits past the decimal point so that if I'm using this on WebAssign, I don't wind up getting the problem wrong from any rounding errors. Once I have that time, the rest of the problem becomes really easy. So question 2 says, well, how fast was the ball thrown? So if I go through, I'm just going to look at my picture here. All right. My unknown here is this VIX. This is how fast was the ball thrown. And I just went through all that trouble to get the time that this thing was in the air. So here, let me write that again. That says time equals, we found 7.836 seconds. All right, so the trick is that, well, we know that the ball lands 104 meters away. That's part of our given information. We call that the range. That's at that dx. So if I look in that horizontal direction, okay, since I've got information about this displacement x, this range, all right, if I write my displacement equation, d equals VIT plus 1/2 AT squared. All right, well, this can simplify because, well, the acceleration here in the problem is 10 meters per second squared, but that's down. That's the acceleration of gravity. That's an AY. There is no gravity left and right, which means that in this problem, if I just look horizontally, there is no acceleration in that x direction. That AX is equal to 0. And so all this cancels out, and I'm left with this very simple relation of dx is equal to VIX times the time. So here, let me rewrite that just so that that second part of the equation isn't even there. VIX times t. And this problem is asking me for, well, how fast was the ball thrown? They want VIX. So, looking back down at what I've got left here, d is equal to velocity times time. Well, hey, if I take that and I rearrange that so that I isolate velocity, look what happens. VIX is equal to dx divided by t. And really all this is the very first equation we learned in physics, which it just says the speed, in this case it's in the horizontal direction, but this is still just a speed, is equal to the distance divided by time. So let's finish this problem. Looking back at my picture, my range, or my dx, is 104 meters. I know this because, well, it's in the given information. The time we solved for that in part 1 is 7.836 seconds. So all we have to do is plug it into velocity is equal to distance over time, where we're just being mindful of the direction. VIX is equal to 104 meters divided by the time of 7.836 seconds. Throw that in your calculator, and I already have VIX is equal to 13.272 meters per second. And so how fast was this ball thrown off this cliff? At 13.272 meters per second. So that about wraps up this screencast. Now you need to go back, select your own numbers, and try working these horizontally launched projectile problems for yourself. Good luck.